Hello everyone. Today, we are going to look at a classic kinematics problem from irodov, shown here in diagram. Let's break it down step by step. The problem states, a point traversed half the distance with a velocity v0. This means the first segment of the journey is defined by distance and speed. Next, it says, the remaining part of the distance was covered with velocity v1 for half the time, and with velocity v2 for the other half of the time. This adds a layer of complexity where the second half of the total distance is split into two equal time intervals. Finally, we are asked to find the mean velocity of the point averaged over the whole time of motion. This is a fantastic exercise in understanding how to bridge distance-based motion and time-based motion. Pause the video for a moment and try this question. Let's continue our analysis of the motion problem using the diagram. First, let's establish our foundation. Let the total distance be s and the total time taken be t. As we know, the mean velocity, denoted by v, is defined as the total distance divided by the total time, v, is equal to st. Now, let's look at the first section, which I've labeled 1. Breakdown of the first half. As you can see from our sketch, the point covers the first half of the distance, which is s over 2, with a constant velocity v0. The time taken for this segment, which we call t1, is calculated by dividing distance by velocity. So, t1 is equal to distance velocity is equal to s/2 v0, which simplifies to s 2 asterisk v0. Now, let's move on to the second part of our problem, which you can see in the diagram breakdown of the second half. The remaining distance, which is s over 2, is covered over a total time interval t2. Within this interval, the point travels at velocity v1 for the first half of the time, t2 over 2, and at velocity v2 for the second half of the time, t2 over 2. Because distance is velocity multiplied by time, the total distance for this segment is the sum of the distances covered in each subinterval. So, we can write s over 2 equals, in brackets, v1 times t2 over 2, plus, in brackets, v2 times t2 over 2. If we factor out t2 over 2, the equation becomes s over 2 equals t2 over 2 multiplied by the sum of v1 plus v2. By cancelling the denominators and rearranging, we can solve for t2 to get our final expression for this part, t2 equals s divided by the sum of v1 plus v2. This gives us the time taken for the second half of the journey. We have finally reached the final step in our derivation, as shown in diagram, calculating mean velocity. We know the total time t is the sum of the times for both segments, so we have t equals t1 plus t2, which equals s over 2 v0 plus s over the sum of v1 plus v2. Now, substitute t into the formula for mean velocity, v equals s over t. This gives us s divided by the sum of s over 2 v0 and s over the sum of v1 plus v2. By cancelling s from the numerator and the denominator, we simplify the expression to our final result, v equals 1 divided by the sum of 1 over 2 v0 and 1 over the sum of v1 plus v2. And there you have it, the complete expression for the mean velocity of the point. Let's start with the complex fraction we derived last time. V equals 1 divided by the complex fraction with the numerator of open bracket v1 plus v2 close bracket plus 2 v0 and a denominator of 2 v0 times open bracket v1 plus v2 close bracket. This is essentially 1 divided by the sum of our two time-based fractions. To simplify this, we can invert the complex fraction in the denominator. This gives us v equals to v naught times open bracket v1 plus v2 close bracket, all divided by open bracket v1 plus v2 close bracket plus 2v naught. Finally, by rearranging the terms in the denominator, we arrive at our beautiful, fully simplified final formula for the mean velocity, v equals to v naught times open bracket v1 plus v2 close bracket, all divided by 2v naught plus v1 plus v2. This formula now relates the mean velocity directly to the initial velocity v naught and the two velocities v1 and v2 from the second half of the journey. Great work on following along with this derivation. That concludes our lesson for today. Thank you for watching. This content is brought to you by the Ekalavya Educational Channel. Remember to keep learning and keep growing. If you found this helpful, please support our channel by liking, sharing, and subscribing.